Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over steps on how to balance your chemical equations. So let's get into this. So I'm going to go over the steps and then I'm going to go over a few examples to show you how I employ or use the steps to balance equations so you could see for yourself how the steps work. So let's get into this. So the steps here are kind of in an order of priority, but not too much, right? So you start with step one, balance metals first before non-metals. So that is a rule of thumb. Um, Rule two, you could put rule two first or step two first. It doesn't really matter. But the idea here, these are general rules of thumb to follow. So first, the idea is to balance any metals you have before non-metals. That they tend to be the easier ones. And then also, rule of thumb is if you have an element that's by itself, that it's not part of a compound, like for example, oxygen gas, hydrogen gas, chlorine gas, sodium metal, something like that, you want to save that for last. Now, if you have a situation where you have more than one element that's by itself, then follow the general rules, right? So, for example, if you have a metal like sodium by itself and you have oxygen by itself, well, rule number one or step one follows. Balance the metal first before the non-metal. And so if I had oxygen by itself and I had sodium metal, I would just go ahead and balance the sodium first, and then I would leave oxygen last. Okay, or if I had hydrogen, I would balance hydrogen last. Now, what if you have two non-metals, right? So if you have hydrogen gas and oxygen gas, then you would follow the other rules as well, right? So here we're rule number three, or I should say step three, balance all non-metals except for hydrogen and oxygen. So after I balance my metals, then I'm going to balance the nonmetals. In this case, I'm going to balance all of the nonmetals first, except for hydrogen and oxygen. So if I have carbon, phosphorus, nitrogen, anything like that, I'm going to balance those first. And then if I have hydrogen and oxygen, I'll deal with them later. So balance your carbon, balance your nitrogen, balance your chlorine, your phosphorus, balance those first, and then do your hydrogen and oxygen. And then for four, finally, when you have hydrogen and oxygen, you balance typically hydrogen first before oxygen. Unless, of course, you have hydrogen as an element by itself, and then your oxygen is part of a compound, right? So in that case, follow step two, right? So if you have an element by itself, save that for last. So if you have hydrogen by itself and oxygen is part of a compound, not by itself, save the hydrogen for last, balance the oxygen first, right? So again, it just depends on the situation you're in. So typically, all things being equal, you would balance hydrogen before oxygen, save oxygen last. Usually oxygen is saved for last, but again, it depends on step two. If you have oxygen as an element or something else as an element by itself, then you would save that for last. Finally, number five, for the last element, whatever the last element is, if you use a fraction to balance it, and you can, right? So I would encourage you to balance it using a fraction if you need to use a fraction, right? So if you have, for example, an odd number of say, for example, let's say oxygen. If I have an odd number of oxygen atoms on one side and I have O2 on the other side, I'm going to use a fraction to help me balance and get 5 on the other side. And I'll show what I mean by that. But if you do use a fraction, you don't always need to use a fraction. But sometimes it's very, very useful to simplify the problem to use a fraction as a coefficient. If you do, multiply the whole equation by the factor that's going to get rid of the fraction. So for example, if I have 2.5 as a coefficient, because I'm going to multiply 2.5 by 2 to get 5 oxygen atoms, then I'm going to get rid of that 0.5, I need to multiply by 2. I'm going to multiply all of the coefficients in my balanced equation by 2 to get rid of the fraction, and yet I'm going to keep the equation balanced by not upending the balancing that I already did. Okay, and then last but not least, double check your work. Simplify coefficients if necessary. So if you have all your coefficients are divisible by 2, then divide them all by 2 to get simpler whole numbers. So you should watch out for that. Okay, so those are the steps. Let me next go through a few examples of balancing equations where I'm applying the steps, so that way you could see what I'm doing. So stay tuned. Okay, so here are a few examples that I want to go over. So let's start with number 1. So again, step 1, metals before nonmetals. So here I have aluminum metal, I have oxygen. So I'm going to balance the aluminum first. Now the other thing I want to note here is step 2. It says that if you have elements by themselves, or if you have an element by itself, save it for last. But here we have 2 elements by themselves. We have aluminum and we have oxygen. So aluminum is not part of a compound here, and oxygen is not part of a compound here. So which one do we choose? Well, we go to the other rules or steps to help us. So in the step here, we still use step 1, or the rule that we do metals before nonmetals. So even though we have 2 elements here that are by themselves, the rule or step number 1 still applies, that you balance the metal before the non-metal, right? So I'm going to save the O2 for last, balance the aluminum first. So here I have aluminum, I have 1 aluminum here, and I have 2 aluminums here. So remember, the way you can figure out how many aluminums or how many of each atom you have, take the coefficient, multiply by its subscript. So here I have a coefficient 1, I have a subscript 2, 1 times 2 is 2. Here I have 1 times 1 is 1. Here I have 1 times 2 is 2. So I have 2 aluminums on this side. I only have 1 on this side. The only way you're allowed to balance your chemical equation is by changing coefficients. You are not allowed to change the subscripts. So never, ever, 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 ever change subscripts. You got to listen to Taylor Swift on this one. Never, ever, 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 ever change subscripts. Only change the coefficients. So here I need to put a 2 coefficient. So 2 times 1 is 2. I have 2 aluminums on this side. I have 2 aluminums on this side. Now the aluminums are balanced. The only other element I have is oxygen, so that's last. So here I have 2 oxygens. Here I have 3 oxygens. Here's where you can use a coefficient, or I'm sorry, a fractional coefficient. But before I show you that, let me just show you without a fraction. So here, you'll notice I have 2 oxygens. Here I have 3. So here you're going to need to find a common factor between O2 and O3. So what number of oxygens do 2 and 3, these numbers, these subscripts 2 and 3, what number are they both factors about? What's the smallest number that I can find them as a common factor? And that would be the number 6, right? So 2 is divisible into 6, 3 is divisible into 6. So I need 6 oxygens for both sides. So in order to get 6 here, I need 2 times 3 will give me 6. So I need a 2 coefficient. What times 2 gives me 6? Well, 3 times 2 gives me 6. So I need a 3 coefficient there. So now I have 6 oxygens on both sides. So the other way you could kind of look at it is you can do kind of a crisscross or cross over with the coefficient or with the subscripts. Oops. Sorry about that. So you can take, since I have a 3 subscript there and a 2 subscript there, you can see that they cross over. So the 3 subscript becomes a 3 coefficient over here. 2 subscript becomes a 2 coefficient there. So you can use that as a strategy as well. Okay, so now my oxygens are balanced, but look, my aluminum is no longer balanced. So I have 4 on this side. 2 times 2 is 4. And I have 2 times 1 is 2. So I have 2 on this side. I have 4 on this side. So I'm going to have to rebalance the oxygen or rebalance the aluminum. So I'm going to need to change this 2 to a 4. And now we have it balanced. So that's one way to do it. But then we can also use a fraction. So if I change this back to a 2, change this back and change this back. So here I have a 2 now. Now I can balance using a fraction also. So if I have 3 oxygens on this side, how would I get 3 on this side? So what times 2 gives me 3? What could I multiply 2 by to get 3? If you said 1.5, you'd be correct. Well, how can you figure that out? So if you don't see what I did, here's what you can do. I need a coefficient when it's multiplied by 2 is going to give me the total number of oxygens on this side. The total number is 3. So I need a coefficient, something multiplied by 2, that's going to give me 3. So if we write that as an equation, something, we'll put a question mark there, something, or we could put an X there if you want to do some algebra. So X times 2 gives me 3. So I need to figure out what X is. What times 2 is going to give me 3? So if I take and divide by both sides by 2, then I get X is equal to 3 halves or 1.5. So I know my coefficient has to be 1.5. So I put a 1.5 here. And now my equation is balanced. Do you disagree? Let's double check. So I have 2 aluminums. 1 times 2 is 2 aluminums. 1.5 times 2 is 3. 1 times 3 is 3. So it's balanced. Now, we don't want to keep it this way. So we don't use fractions usually. Not, sometimes, but normally we don't have fractions as coefficients. So we need to get rid of this 0.5. In this case, we need to multiply by 2. So we're going to multiply the whole equation by 2 because it's already balanced, and we want to keep it balanced by making sure that we multiply everything by the same factor. So 2 times 2 is 4. 1.5 times 2 is 3. And 1 times 2 is 2. So we're back to where we were before. And so we have a balanced equation. Let's go ahead into the next one. So for number 2, I have nitrogen plus hydrogen gives me ammonia. So N2 plus H2 gives me NH3. So again, we're going to follow the steps. Step 1, metals before nonmetals. We don't have any metals, so we can skip that step. Step 2, we want to balance any elements. Any element that we have by itself is going to be last. But here we have 2 elements by themselves. So which one are we going to say for last? Well, in this case, if you go to step 3, step 3 says balance every other non-metal and leave hydrogen and oxygen last. So we don't have oxygen, but we do have hydrogen. So in that case, I would balance nitrogen first and then balance the hydrogen next. So here I have nitrogen, I have N2, I have 2 here. I only have 1 here, so I'm going to need to put a 2 coefficient here. So 2 times 1 is 2. So now my nitrogen is balanced. So now I go to hydrogen. So I have 2 hydrogens here. I have 2 times 3 is 6. So I have 6 hydrogens on this side. So I need 6 on this side. So what times 2 is going to give me 6? 3. So 3 times 2 is going to be 6. Now the hydrogens are balanced. Everything is balanced. So that's number 2. Let's go to number 3. So here I have CO plus H2 gives me C8H18 plus water, H2O. So step 1, balance your metals first. I don't have any metals here, so we can skip that step. Step 2, if you have an element that's by itself, save that for last. So you'll see here that I have hydrogen by itself. It's not part of any compound, so I'm going to balance that one last. So everything else I'm going to balance first. So step 3, balance all your other nonmetals before your hydrogen and oxygen. So in this case, I have carbon, and I have oxygen, and I have hydrogen. So hydrogen, I already said, is balanced first, but I'm going to balance carbon before the other 2. So I have 1 carbon here, but I have 8 carbons here. 1 times 8 gives me 8. So what times 1 gives me 8? 8. So I need an 8 coefficient there. Now my carbons are balanced. Now I can go to the oxygen. Now, according to the next step, when you have hydrogen and oxygen last, balance hydrogen before oxygen. But as we said, we have hydrogen here by itself, not part of a compound, so we're going to save hydrogen for last. So we're going to balance oxygen first. So we have 8 oxygens here. 8 times 1 is 8. So I need 8 oxygen on this side. So here I have 1 oxygen. So what times 1 gives me 8? Well, 8 is going to give me 8. Okay, so now my oxygens are balanced, and now I have hydrogen left. So here I have 2 hydrogen. How many hydrogens do I have on this side? I have 18 from this molecule. 1 times 18 is 18. So I got 18. And then I have 8 times 2 is 16 from the water. So I'm going to add 16, and that's going to equal what? So 18 plus 16 gives me 34. So I have 34 hydrogens on this side. Okay, so I need 34 on this side. So what times 2 gives me 34? 17. So I put a 17 there. Everything is now balanced. So that's how you balance that equation. Number 4. Here I have iron plus sulfuric acid is going to give me iron 3 sulfate plus my hydrogen. So metals before nonmetals, that's step 1. Also, step 2, if you have an element by itself, save it for last. Now we have 2 elements by themselves, but if we follow the first step, metals before nonmetals, we're going to balance iron first anyway, so we're going to save hydrogen for last. So again, normally we would leave oxygen if we're following the steps, but because step 2 tells us elements by themselves are to be saved for last, we're going to save hydrogen for last. So we're going to balance the iron first. So I have 1 here, I have 1 times 2, I have 2 here. So I need a 2 coefficient here. 2 times 1 is 2. So now my iron is balanced. So metals are balanced. Now I'm going to go to nonmetals. Again, step 3 says that if you have nonmetals left, you're going to balance all the nonmetals except for hydrogen and oxygen. You're going to save hydrogen and oxygen for last. So I have sulfur here. So I'm going to balance the sulfur. Here I have 1 sulfur. Here I have 3 times 1 inside the parentheses multiplied by whatever this is. So it's going to be 1 here times 1 times 3. So that's going to give me a total of 3 sulfates or sulfurs on this side. So 3 times the 1 times the 1 gives me 3. So I have 3 on this side. I need 3 on this side. So I need a 3 coefficient. 3 times 1 is 3. So my sulfurs are now balanced. Okay. Now all I have left is oxygen and hydrogen. And we're going to save hydrogen for last because that is an element by itself. So we're going to do oxygen next. So here I have 3 times 4 is 12. I have 12 oxygens on this side. And here I have 1 times 3 is 3. 3 times 4 is 12. So I have 12 on this side. So my oxygens are already balanced. So let's take a look at our hydrogen. So we have 3 times 2 is 6 on this side. We only have 2 on this side. So what times 2 is going to give me 6? 3. And now the hydrogens are balanced. There you go. Let's go to the next one. So here we don't have any metals, so we can skip that step. But again, if you have an element by itself, save it for last. And here we have oxygen. Oxygen by itself, we're going to save that for last. So next step is if you don't have any metals, or if you've already balanced your metals, then you're going to balance all the nonmetals except for hydrogen and oxygen. So we have carbon here. So we're going to balance that first. We have 1 times 2 is 2 carbons here. I have 1 carbon here. 1 times 1 is 1. So I need a 2 coefficient. 2 times 1 is 2. So now my carbons are balanced. So next is hydrogen and oxygen. Since I have oxygen by itself, that's last. So I'm going to go ahead and do hydrogen. So here I have 6 hydrogen. Here I have 2 hydrogen. So I want to balance this. So what times 2 gives me 6? 3 times 2 gives me 6. So now my hydrogens are balanced. What's next? Oxygen is last. So here I have 2 oxygen. Here I have 3 times 1 is 3 oxygens from the water. And I have 2 times 2 is 4 from the carbon dioxide. So that gives me a total of 7 oxygens on this side. So I have 7 oxygens on this side. I only have 2 on this side. So I can use a fraction. So what times 2 gives me 7? Well, I can work it out, right? I can do it down here. So I need a coefficient. We'll call that x multiplied by 2. That's going to give me the desired number of 7. I want 7. So what does x have to be? So if I divide both sides by 2, then x is equal to 7/2 or 3.5. So I need a 3.5 coefficient for my oxygen. So 3.5 is the coefficient. So we can all agree that 3.5 times 2 is 7. So that's going to balance the 7 oxygens I have on this side. So everything is technically balanced, but we can't keep the fraction. So because I have a fraction of a 0.5, I need to multiply by 2. So I'm going to have to multiply my whole equation all by 2. So all coefficients are multiplied by 2. So 1 times 2 is 2. 3.5 times 2 is 7. 3 times 2 is 6. And 2 times 2 is 4. And there, ladies and gentlemen, you have your balanced equation. You can check it to make sure that it's balanced, but it is all balanced. And finally, my last one. Here I want to show you another rule that's helpful. If you have polyatomic ions in your equation, if the polyatomic ion stays the same on both sides, you can balance the whole thing as one unit. Rather than counting each atom in the polyatomic ion and doing it separately to see if all the atoms balance, you can just you can balance it as a unit. So what do I mean by that? So let's balance this one. So metals before nonmetals. I have potassium, which is a metal, so I'm going to balance that first. So I have 1 potassium here. I have 2 potassiums there. So I'm going to need to put a 2 coefficient here. So now the potassiums are balanced. So now all my metals are balanced. I'm going to balance the nonmetals. But what you notice here is I have NO3, which is nitrate here, and I have NO3 as a nitrate there. I can balance that as one whole because it stays together. Same thing with CO3 carbonate. So I have a carbonate polyatomic ion here, and it stays together over here. So rather than balance the carbons separate from the oxygens and balance the nitrogen separate from the oxygens, I can just balance them all together. So here I have 2 nitrates. So I have a 2 times 1 of these. I have 2 of them. So I have 2 nitrates on this side, but I only have 1 nitrate on this side. So I'm going to have to put a 2 coefficient here. So now I have 2 nitrates and 2 nitrates. So the nitrates are balanced. Here I have 1 carbonate and I have 1 carbonate. So that's already balanced. So last but not least, I have the hydrogens. So in this case, notice that if I follow the steps, I would save oxygen for last. But because I was treating the polyatomic ions as wholes and the oxygen is part of the polyatomic ions, I ended up balancing the oxygens along with everything else. But now I have hydrogen and hydrogen is last. So I have 2 hydrogens here, and I have 2 times 1 is 2. So the hydrogens are balanced. And that, ladies and gentlemen, is how you use the steps. I hope this is helpful. If you enjoyed this video, if you liked this video, if you learned something from this video in any way, shape, or form, please like the video. Hit that like button. It's right over there somewhere. Also, make sure you subscribe to my channel. Hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question, if you need help with anything, put that down below. I would love to do that for you. If you have a topic you want me to cover, put that down below. I would love to do that for you. Thanks for joining me. Have a great day.